Chapter 7, Miscellaneous. Question number 17. Integration f dash ax plus b times f ax plus b power n dx. Here, if we put f ax plus b equal to t, then we will get f dash ax plus b dx as dt. Put f of ax plus b equal to t, f dash ax plus b dx equal to dt. So our question will become t power n dt, which is equal to t power n plus 1 divided by n plus 1 plus c. That is f ax plus b power n plus 1 divided by n plus 1 plus c. Question 18. Integration dx upon square root of sine cube x times sine x plus a. Here we expand this. So integration dx divided by sine cube x under root sine x cos a plus cos x sine a. If we take out sine x, then this will become cos x upon sine x. Integration dx divided by root of sine power 4x. Then here cos a will be left, and here this will become cot x times sine a. Now this will become outside square root sine square x, and 1 upon sine square x will become cosec square x. So we write it as cosec square x dx divided by root of cos a plus cot x times sine a. Now let's take this denominator equal to t. Put cos a plus cot x times sine a equal to t minus cosec square x times sine a dx equal to dt. And now next step you have to take. Question number 19. Sine inverse root x minus cos inverse root x divided by sine inverse root x plus cos inverse root x dx integration. Here, if you remember the property, sine inverse a plus cos inverse a equal to pi by 2. So that property we can apply here. So denominator will become pi by 2, and in numerator we can replace cos inverse root x by pi by 2 minus sine inverse x. So integration sine inverse root x minus pi by 2 minus sine inverse root x whole dx divided by pi by 2, which will be equal to twice of sine inverse root x minus pi by 2 divided by pi by 2 divided by pi by 2 whole times dx. So it will become 4 upon pi integration sine inverse root x dx minus integration dx. So second term will become x. This term is to be integrated. So let's write it as 4 upon pi integration sine inverse root x dx minus x plus c. And let's take this term as I and differentiate it, sorry, integrate it again. And then we will put this value, the value swapped in here. Okay, so let's proceed. So we have taken I equal to integration root of, sorry, sine inverse root x dx. Here, if we put root x equal to t or x equal to t square and we differentiate it. So dx equal to 2t dt. So our question will become integration sine inverse t times 2t dt or twice of t sine inverse t dt. Here we apply I-late rule in which t will be taken as second function and this will be taken as first function. So it will become twice of sine inverse t times, when we integrate it, it will give t square upon 2 minus integration. Differentiation of sine inverse t will become 1 upon root of 1 minus t square times integration of this will give t square upon 2 dt. Now, further, it will become 2 will cancel out. So t square times sine inverse t. And from here, it will become 1 by, when this 2 will get multiplied to this term. So 2 will cancel out. So integration t square dt divided by root of 1 minus t square. Now, we can write here this t square as t square. We can include this minus sign inside. So we integrate this term further. So we will get t square sine inverse t minus, okay, write as plus, and here we can include 1 minus t square and then minus 1. Here this minus sign has made this t square negative. So minus t square and 1 I have added and 1 I have subtracted. Divided by root of 1 minus t square divided by root of 1 minus t square whole dt. So now it will become t square sine inverse t plus integration root of 1 minus t square dt minus integration of dt upon root of 1 minus t square. So we can apply formula. So this term will give sine inverse t, and here this term will become so we will get t square sine inverse t, and this will become t by 2 by using formula root of 1 minus t square plus 1 by 2 sine inverse t, and this is sine inverse t. So, and plus c. Now, if we simplify, so we can take sine inverse t common. There are three terms here, this. So, t square minus half times sine inverse t plus t by 2 root 1 minus t square plus c. So we can put the values of value of t when we put, so our equation will become 1 by 2. Then we have assumed earlier as t square equal to x. So this will be 2x minus 1, and then sine inverse t is root x plus this will become 1 by 2 root x times root 1 minus x plus c. So putting these values in previous equation from where we assumed it as I, so we can say integration sine inverse root x minus cos inverse root x divided by sine inverse root x plus cos inverse root x dx gives 2 upon pi 2x minus 1 sine inverse root x plus root of x minus x square when this term gets multiplied inside plus c. Now let's go to next question. Question number 20. Integration root of 1 minus root x divided by root of 1 plus root x dx. Here we take root x equal to cos t, or from here we can get t equal to cos inverse root x. Now this will give x equal to cos square t. So we differentiate it, so this will give dx equal to 2 cos t times minus sine t dt. So we replace these values here. So it will give integration root of 1 minus cos t divided by 1 plus cos t times minus 2 sine t cos t dt. So we can write it minus 2 integration root of, if you remember, 1 minus cos x equal to 2 sine square x by 2, and 1 plus cos x equal to 2 cos square x by 2. So that value we can put here. So 1 minus cos t will become 2 sine square t by 2 divided by 2 cos square t by 2 times sine t cos t dt. So from here, 2 will cancel out. This will become tan t by 2. So minus 2 integration tan t by 2, and this is sin t cos t dt. Now, next step is we write it minus 2 integration. This is sin t by 2 divided by cos t by 2, and sin t can be written as 2 sin t by 2 cos t by 2 times cos t dt. Here cos t by 2 will cancel out, and this 2 will become 4. So minus 4 integration sine square t by 2 times cos t dt. Further, since 2 sine square t by 2 equal to 1 minus cos t. So here we can write it as minus 2 times 2 sine square t by 2 cos t dt, and in place of 2 sine square t by 2 we can write 1 minus cos t. So we will get minus 2 times 1 minus cos t times cos t dt. So if we open the bracket, we will get minus 2 cos t minus cos square t dt. So further, cos square t can be expressed in terms of cos 2t. So our next step will be integration cos t dt, and this 2 can be carried to next step also. So 2 integration cos square theta can be written as, since 1 plus cos 2 theta gives 2 cos square theta. So here we have cos square theta. So that will be 1 plus cos 2t divided by 2 dt. So this cos t will give sin t, and this 2 will cancel out, and this 1 will give t. This cos 2t will give sin 2t divided by 2 plus c. Now we go back to put the value of t. So we can write minus 2, this root of 1 minus cos square t plus t plus 2 sin t cos t divided by 2 plus c, and sin t can be expressed in terms of root 1 minus cos square t, because our assumption was in terms of cos twice of 1 minus cos square t plus twice 2 will cancel out, root of 1 minus cos square t times cos t plus c. So we can put the value. So it will become minus 2, and our assumption was root x equal to cos t. So this is cos square t, so it will become x. So root of 1 minus x plus t will be equal to cos inverse root x plus cos t will become root x, and 1 minus cos square t under root will become root 1 minus x plus c. If we want to further simplify, so it will become minus 2 root 1 minus x plus cos inverse root x, and this root x can be taken inside, so it will become x minus x square under root plus c, which is our answer. Thank you for watching.